Relativity is a theory formulated and proved by Albert Einstein that said motion, whether uniform or non-uniform, must be compared to a frame of reference, and that space and time are not absolute quantities. How will Albert Einstein consider it when some object is in motion, time slows down? This type of thinking was considered when Albert Einstein considered the speed of light, which is c in his equation, to be constant for all frames of references. Now, the theory of relativity is divided into two parts: special relativity and general relativity. Let's start with first amazing thing about special relativity, that is length contraction. Length contraction is the shrinking down effect when someone or some object is in motion. Next is the most amazing effect of special relativity, that is time dilation. Suppose Rohan is standing on a railway platform and waving hi to his friend Arnav, who is going on a train. So Rohan waves hi to Arnav, and Arnav, instead of waving hand, shows a light clock or a photon clock. So if we compare the two frames of references, Arnav will see the photon bouncing up and forth, and Rohan will see the photon bouncing not up and forth but in a triangular path due to the velocity of that train. So if speed is same and distance is different, then time must be different, and that is one of the most key principles of time dilation. There are a couple more interesting consequences of special relativity. Like relativity of simultaneity, which means that one observer can see two different events at some other time than some other observer. Or there is relativistic mass, which means that if you try to travel close to the speed of light, your mass starts getting increased, and that is one of those primary reasons that you can't travel to the speed of light. We have done enough research on special relativity, so let's move on to general relativity. General relativity in its core is a gravity theory and describes how the cosmic material interacts with the force named gravity. Now the consequences of general relativity is gravitational time dilation, which in a way is like the stronger you experience a gravitational pull, the more time for you will pass. So what happens when space-time, which you consider this, if you consider this piece of paper, gets stretched very much, a black hole is formed? Or what happens when space-time gets folded and a hole is created where a finger is there? A wormhole is formed. This will be our next episode's topic. So subscribe, like and comment to the crazy ones. Thanks for watching.